All right, good morning, students. Today we're going to be doing 7.3. We are going to be analyzing geometric sequences and series. First, let's define geometric sequence. A geometric sequence is multiplying by the same number. We're going to call that number R. Multiplying by the same number to make the next term. So an example of a geometric sequence might be 4, 12, 36, and so on and so forth. So times 3 times 3. So our R for this one times 3 times 3. So R equals 3. For this example, our R value or our rate is 3. All right, let's check out our first one. Example number 1. Actually, before we do example number 1, what is the formula for a geometric sequence? A geometric sequence is a to the n equals a to the first, which is your first value, times your rate, times your to the exponent n minus 1. So that's your geometric sequence formula. So now that we know that, let's see example 1. So example 1, write a rule for the sequence 5, 15, 45, 135, and then find the 20th term. Okay, so the first thing I'm going to put up here is what our geometric sequence formula is. So a to the n equals our first value times our rate to n minus 1. Okay, so let's look at this one. Let's plug our numbers in. So a to the n equals our first value, which is 5, times our rate. Well, what's our rate? So from 5 to 15, that's times 3. 15 to 45, that's times 3. 45. So our rate, our R, equals 3. So our R is 3, and then n minus 1. Don't combine these, because don't forget you do parentheses and exponents, then multiplication. So that's our formula right there. So there's our rule. And now we want to find our 20th term. So a to the 20th equals 5 times 3, and then our 20th term minus 1. So I could simplify it a little bit by doing 3 to the 19. Now, if you're going to use a calculator, you have to be very careful about parentheses. Make sure you put the parentheses in. So if we look, it's 5 times 3 to the 19th power. Okay, and that's a big number. So geometric sequences increase quickly, as you can see. So we have 5, 8, 1, 1, 3, 0, 7, 3, 3, 5. So we have 5,811,307. I'm sorry, 5,811,307,335. So that is our 20th term. So in this sequence, first term, second term, third term, fourth term, all the way to our 20th, that's our 20th term. So as you can see, geometric sequences increase or ramp up very quickly. All right, number 2. Example number 2. We have write a rule for a geometric sequence where a to the third equals 54 and a to the sixth equals 1458. Okay, so you notice we don't have our first term. So like yesterday, we did the whole 1, 2, 3, and we have 6. I'm just going to write them all out. 1, 2, 3, 4, 5, 6. So a to the 6, 1458. 1, 2, 3. A to the third is 54. So let's see. Well, I guess we're going to have to make this a to the first. So that was 3 minus 2 equals 1, so a to the fourth. So let's do a to the fourth equals a to the first times r to the 4 minus 1. Okay, so we're using the same formula. A n equals a1 r n minus 1. So I have a to the fourth equals a1 times rate times n minus 1. Now we know what a to the fourth is for our modified red version. It is 1458 equals, and then a to the 1 for our red version when we subtract the 2 is 54 times r, and then we know that this is 4 minus 1, so this is to the third. How do we solve this? 1, 4, 5, 8 equals 54 times r to the third. Well, I can divide by 54. So those cancel out. And then 1458 divided by 54, you get 27 equals r to the third. So 27 equals r to the third. How do I solve that? Well, I get the third root and the third root. Well, the third root of 27 is actually 3. 3 times 3 is 9 times 3 is 27. So 3 equals r. So our rate for these is r. So now what I'm going to do is I'm going to go up here, and don't forget this is our rate for geometric sequences multiplied by. So if I go this way, I'm multiplying. If I go this way, I'm dividing. So 54 divided by 3. 54 divided by 3 is 18. 18 divided by 3 is 6. So now I have my real A1. Now I could do this again. Excuse me. A to the n equals A1 times R n minus 1. So now I can find my actual geometric sequence formula because I have my first value, which is 6. So I have my rate, which is 3, and my A1, which is 6. So A to the n equals 6 times 3 to the n minus 1. So there's my formula. And again, don't combine these. All right. Cool. There's your answers. All right. Now, what we're going to do is we're going to change. So that we just did our sequences. So we were finding sequences. And now we're going to go to geometric series. And geometric series, don't forget, series just means sum. Series just means sum. If you add everything together. So the sum for a specific number in a geometric series is the first value times 1 minus r to the nth over 1 minus r. And I'm going to put these in parentheses, and you'll see why I put these in parentheses. It's for the calculator. So example number 3, using our geometric sequence, is we are going to find the sum of the first 20 terms of 2 plus 6 plus 18 plus 54 plus 162. We're going to find the sum of the first 20 terms. So we're going to use this formula. So first, let's find our rate. So times 3 times 3. Okay, so our r equals 3. So we're going to plug that into this formula. Sn equals a1 times 1 minus r to the n power over 1 minus r. So Sn, we're looking for our 20th term. So our 20th term equals our first term, which is 2, times 1 minus our rate, which is 3, to the nth power. And so n is 20 over 1 minus 20. So S20 equals, actually, that's what I'm going to put in the calculator, right there. So where's my calculator? So I'm going to put it in exactly like that with parentheses. 2 times 1 minus 3 to the 20th. And then make sure you bring the parentheses back down. So you have 2 times 1 minus 3 to the 20th. And then that whole thing divided by, and you want to make sure you do the parentheses. And there is, oh, I messed up. Time out. This is R, back up. Sorry, I apologize. This is not 20, this is our rate. So this should be the 3. That should be the 3. So this is R, so these two numbers should be the same. Sorry, my mistake. Didn't make a lot of those. So let's do the real equation. 2 times 1 minus 3 to the 20th power. Bring the parentheses back down. And that all divided by 1 minus 3. Whoops. Let's get some parentheses there. So 2 times 1 minus 3 to the 20th divided by the difference of 1 minus 3. Let's see. 3, 4, 8, 6, 7, 8, 4, 0, 0, 0. So if you see that number, it is 3, 4, 8, 6, 7. Sorry, I'm going to move this. 7, 8, 4, 4, 0, 0. So the sum of the first 20 terms of this geometric sequence, so all of them added up, the first 20 terms, is going to be 3,486,784,400. That is the sum of those terms. Okay, sorry about that mistake right there. This is an R and an R. R. All right, last one. Example number 4. We'll find our series. So, example number 4, we have, remember the sum. We're going to find the first 15 terms if our formula for a geometric sequence is negative 3 times 1.5 n minus 1. So for this, what is our rate, if this is our formula. If we look at our formula, we know that right here, our formula shows us that it's the first term times the rate. So our R value is 1.5. R value is 1.5. So we're going to find the sum for the first 5 terms. Our formula, let's find our first term first. So a to the 1 equals negative 3 times 1.5 times our first value minus 1. So our 1 is here. So negative 3 times 1.5 to the 0. We know 1.5, anything to the 0 power is 1. So 1 times negative 3 is negative 3. So our first value is negative 3. Now we get to plug that into our sum, our geometric sequence series, which is a1 times 1 minus r to the nth value over 1 minus r. So a1 value is negative 3 times 1 minus our rate, which is 1.5 to the 15th, because that's what we're doing our sum to, is s to the 15. And that is all over 1 minus 1.5. So I am just going to plug that into the calculator. So we have negative 3 times 1 minus 1.5 to the 15th, and all of that divided by 1 minus 1.5. Make sure you put this into parentheses. And we get negative 2621.36 blah 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 blah. So it keeps going, but I'm going to round it off to the hundredths place. So the sum of the first 15 of terms 1 through 15, the sum is negative 2,621 and 36/100ths. Okay, there's your examples. Your homework is page 208, numbers 1 through 12, and you can skip number 11. All right, let me know if you have any questions.